Hello students and welcome to my channel. My name is Mr. Meshak Ngige and welcome to eMaths with Mr. Meshak Ngige as we learn concepts through engineering mathematics. And today we're going to be checking something we call the gradient, or something called in short form we call it the grad. Okay, so if you've not subscribed, kindly subscribe, share and also comment to make sure that these videos reach as many people as possible, and also to help me to grow this particular channel. Now let us jump right into the question of today, that is the gradient. Remember, we are still in the topic vector analysis. If you have not seen the videos of dot product and cross product, area of a triangle spanned by two vectors, and also area of a parallelogram spanned by two vectors, the angle between vectors, kindly check the videos in the playlists called vector analysis. All right, so you can just go into my channel, click in the icon button, then you'll get into the channel. Then from the channel you shall see playlists, and from the playlists we have a number of topics there. You will choose vector analysis and kindly follow on the videos. Now we have something called gradient here, and I can call it grad. That is the short form. So again, we are checking questions directly from your papers, right? Yes, so we are doing kind of a revision here, right? Now, given that phi is given by x squared y z cubed and x y squared z squared, determine any time you see this, it means you're supposed to get the gradient. Now sometimes you might not be told directly to get the gradient. Are we together? Yes, so you need to know the representation, okay, of these particular letters here, and these are Greek, okay, at point 1, then 3, then 2. So the first thing that you need to remember is how to define grad. So grad is defined by what? Now we have this part and we have this. Now phi is always a function, okay, it is just any function. This delta is our operator, okay, this one is just our operator, right, together. So we shall have, and it is given by the differential operator, partial of derivative with respect to xi, partial derivative with respect to yj, plus partial derivative with respect to z, then you have k. Then remember, it is not dot product, we're just multiplying by what? Phi is a function, and this is a particular function, which now by the end of the day now just gives us d phi dxi plus d phi dyj plus d phi dzk. Are you together? So when you open this bracket, this is just what we have, but you need to understand every part individually, so that in case you're even given and you really don't remember what it entailed, you can now put everything together and just have your working. Are you together? Now what does this mean? This just means take the partial derivative of your function with respect to x, then you put I. Take your partial derivative with respect to y, then put j. Take your partial derivative with respect to z, then you put k, right? So we have our function here. So for instance, our function d phi, so again I'll just write the representation so that we really get it. Dzk, okay, then I have my function which is x squared y z cubed plus x y squared z squared. So what do we do here now from this point? This is just what we're going to do. We now take d phi, I'll split them into particular elements as we differentiate. It is partial derivative of this function with respect to x. So we are saying differentiate the function where we only have the x variable. treating all the other terms as constants. You don't interfere with the other letters. Only differentiate where we have the variable of differentiation. Are we together? And if the variable is not there, remember we are treating all the other variables as constants. And anytime you differentiate a constant, you get your value to be 0. Are we together? So now let's jump in. So differentiate this function, the whole of it. Do we have an x variable in the first term? Yes, so differentiate x. So drop the power, reduce the power by 1. So it becomes, so I've dropped 2, then x. Then I remain with y, z cubed. Then plus. Do I have an x? Yes, when you differentiate x, you get 1. So you just have 1 y squared, z squared. Then you put out I. Simple. Then again, d phi, dy, then j. Again, now differentiate with respect to y. Do we have y here? Yes. So differentiate y, you get 1. So you remain with what? X squared, z cubed, plus. Do you have y? Yes. Y squared, drop the power. So 2x, reduce the power by 1. Then you have z squared. So you will notice we are not interfering with the other variables as we integrate with respect to the particular variable of differentiation. Sorry, differentiation, not integration. Differentiation. So then we come to the last one with respect to z. So the z is here. So drop 3. X squared remains, y remains, then z becomes comes to power 2, then plus. X, so you have z again, drop 2, so you have 2x, then you have y squared, then z reduces the power to 1, then you have what? You have k. If you are not given these points, then this will be a solution. Just take this term plus this plus that, and you have your solution, because this term here is this term here is what you have here, and this term here is just what we have at this particular position. But now we have been told to find the values at point 1, 3, 2. Right together at point 1, 3, 2. Now I'll do it here. Just have it here at point 1, 3, 2. At point 1, 3, 2. At point 1, 3, 2. So what does this mean? Where I have an x, I put 1. Where I have a y, I put 2. Where I have 3, where I have a z, I put 2. So that is just what we're going to do. So replace your values. So you shall have, so equals to 2 times 1 times 3 times 2 cubed, okay, plus y is what? Y is 3 squared, then z is 2 squared. Okay, so what will we have here? 2 cubed is 8. 8 times 3 is 20, 24. 24 times 2 is 40, 48. Plus, this is 9. 9 times 4, 30, 36. 36 plus that gives me 84. Then I have a note. I have an I. Simple as that. Then I come to the second term. So again, 1 squared, 2 cubed, plus 2. X is 1. Y is 3, sorry. Then z is 2 squared. Again, I just have my value. So this one is 8 times 1 just gives me 8. Plus this one is 4. 4 times 3 is 12. 12 times 2, which gives me 24. So 24 plus 8 gives me 32. Then I put out, I put a J. Then lastly, I have 3 into bracket 1 sorry, 1 squared plus 3 plus 2 squared plus 2, then I have 1, then I have 3 squared, then I have 2. So again, I can have my values. This one is 4. 4 times 3 is 12. 12 times 3 is 36, because 1 squared is just the same value. It's just 1. Then I have 9. 9 times 2, 18. 18 times 2, 36. So this one gives me 72. 2k. So therefore, I think I'll just write my answer so that I can have maybe the second example there. So therefore, my grad will be given by 84i plus 32j plus 72k. And that is how you get your gradient. So let's check a second example. So we have our second example. We have our second example that given phi is given by that. Now remember, again, you don't have to be using phi always. And so remember, a function can be given in any other letter. These are just Greek letters. And by the way, did you know that the first Greek letter is alpha? So can you guess what is the last Greek letter? Now, so we have a function here. So again, we determine the gradient at point 1 to -1. So the same again, this one will be given by, so dx. I always encourage students to write whatever is required so that before you start solving. Okay, so our function is x squared z plus 2xy squared plus yz squared. So again, now I differentiate each function with respect to x and y and z. So d phi dx. So differentiate with respect to x. So do we have x here? Yes. So we'll have 2x, then I have z. So remember, you need to have I. Do we have an x here? Yes. When you differentiate, the x goes, you remain plus 2y squared. Now remember, here we don't have an x. Okay, so we don't differentiate that. And if we differentiate it, we are differentiating a constant. And if you differentiate a constant, you get what? You get 0. So at any point where where we don't have the variable of differentiation, don't differentiate to make it simple. So I, then we have d phi dy j. Again, differentiate that function with respect to y. Do we have a y here? No, so don't differentiate that. Do you have a y here? Yes, so drop the 2. You have 4xy. Do you have a y here? Yes, but it becomes 1, so you remain with z squared. So remember, you have to be good with partial derivatives at least for you to really have an upper hand on this. Again, let's come to the last part. The same function. Remember, we are using the same function. Now differentiate it with respect to z. So do you have a z here? Yes. So differentiate it, you get 1. Okay. So you remain with what? X squared. This one becomes 1. So we literally don't write the 1. So you remain with x squared. Do we have a z here? No. Do you have a z here? Yes. So you drop it to y. Then you have z, then you have what? At this point you'll have k. Then we just input our limits. Again, I always put it here so that we can have a consistency. So 1 to -1 and 1 to, this means at this particular point. Okay, yes. So where we have an x, I put 1, then y 2, then z that. So we have 2, then we have 1, then we have z -1, then plus 2, y is 2, then squared. So this one will be -2. This one is 4 times 2 plus 8, which gives me positive what? 6. So I'll have 6 what? 6i. Come to the second. It is 4, our x is 1, our y is y is 2, sorry, our y is 2, then plus z is -1, then square. Then it gives us 8 plus 1, because you square a negative number becomes positive. So this one gives you 9j. Then the last one, our x is 1, so 1 squared plus 2, our y is 2, then our z is -1. So we shall have 1 minus 4. because 2 times 2 is 4, 4 times negative 1 is negative 4. So this one gives us negative 3k. Therefore, your gradient will be given by 6i plus 9j minus 3k. And that is how you get your gradient. So thank you and see you in the next lesson.